That brings me to, first of all, asking you, if you said that computer science being taken away by AI. I think it had some pun intended to it. So what do you think of that? Like, what do we what are we missing in cognitive science, given that the mainstream cognitive science is computational. It invokes computation, information theoretical ideas, and explanations are also based on the symbolic structures without any evidence of the symbolic manipulation taking place whatsoever.
Well, I think the well, I one example that I used in the book that I like is this question of, what is a robot? Because when we think of what a robot is as we construct them, we think of some kind of a sensing mechanism. There are sensors of some kind that, and then there are transducers, and then there's a computer that takes the information from the sensors, does some processing, and then outputs it into some kind of an effector mechanism, and that's a robot. So you have sensors on the input side, you have a computer to process stuff, and you have effectors on the output side. But if you think of an enzyme, which we talked about earlier, the enzyme has a sensor, which is its binding site, and it has its effector, which is a catalytic site. So it is in a sense a kind of robot. And that the robot metaphor has actually been used in enzymology and biochemistry to talk about what enzymes are, little robots that go around in the cell and do things. But the thing that's missing in an enzyme, of course, is this computer. You've got this, you don't have computation between the input and the output in an enzyme. It's simply a dynamical mechanical process. So when we think about cognition and we think about human behavior, should we be thinking of it as more like a robot or more like an enzyme? And I think that if you think of it more like an enzyme, and I'm not going to say that it is an enzyme because I don't think we have that evidence, but I think if you think of it as more of an enzyme and you try to understand the dynamical properties of cognition and the dynamical properties of behavior and perception, that can actually be very valuable. That getting locked into this sort of computational model is problematic. The other thing I would like to say about computation, certainly in this larger context, is that when I think of computation, I think of Turing machines, and I think of formal computation as a symbol processing system, and I think computation tends to get used so metaphorically now that it's losing much of its meaning. And I would very much like to see people who are talking about computation to kind of stick to our understanding of computation as a symbol manipulation system based on Turing machines and von Neumann architectures and all that kind of thing. That when you start saying, well, the brain is computing, well, what does that mean to say the brain is computing? It is not computing in any formal sense of computation. So what is it doing, and what does calling it computing buy you?
Right. And if it is von Neumann or Turing's kind of symbol manipulation, then you need to have physiological evidence of it, at least in the last 5 decades of or you can say like 6 to 7 decades of research which relied on computational metaphors.
Right, exactly.
Right. So where do you think that now the rate dependent versus rate independent framework can come in and solve some of these confusions and help us understand cognition better beyond language?
Well, that's a great question. you know, the problem with with language and with computation in general is that the brain is primarily a dynamical device, and we're trying to look at it and see if we can find some symbols in there somewhere.
Yeah.
And certainly in the formal idea of what a symbol is, we have not been successful at that so far. That we see a lot of impulses, and we see a lot of synapses, and we see all kinds of organizations and things going on in there. But actually looking for symbols and finding symbols, when the symbols are elsewhere. The symbols are part of our extended cognition, as you say. The symbols are outside. The symbols are in the world, and it's easy to study the symbols because they are in the world. And if you start looking for the symbols in the brain, I'm afraid you're going to be disappointed.
That's true. That's true. So we have set up the basically the field of computational neuroscience on a not a great foundation, basically.
Right.
It's pretty short lived in the sense.
Yeah, I think that's true.